All right. I need to zoom in a little more. That's too much. Oh, that's really messed up. All right, here we go. Okay, 5.2. Relations and functions. I can't for the life of me remember if we even did this last year.
We did.
We did not?
We did.
Okay, I thought we did, but I couldn't remember. So this is going to be basically a review. Okay, so a relation is a set of ordered pairs. Okay, so a relation is a set of ordered pairs. It looks like this, X and Y. That's your ordered pair. Can it be X, Y, and Z?
Yeah.
Huh?
Yeah.
No. It has to be an ordered pair.
Oh, pair.
It's okay. It's okay. So it can't be just X. It can't be just Y. It can't be X, Y, Z. It can't be anything but an ordered pair, X and Y. Okay, so for example, I'm going to give you an example of a set of ordered pairs. Now, if you remember, I'm going to call this A. Let's say A, and it's any letter. It can be any letter here. There's no rhyme or reason why there's an A there. It could be B, it could be whatever. It's just set A is what it is, okay? So set A, a set of ordered pairs looks like this. My little funny, whatever parenthesis group thing. -3 and 5. 2 and 2. 2 and 4. Let's say 4 and -1. And weird bracket thing. This is a set of ordered pairs. That's it. I'm going to try to clear this up a little bit. There, that's better. Okay, so each of these is an ordered pair. A group of them is a set of ordered pairs. That is what a relation is. There you go. We can also write it as a little table. Remember that this is your X and that's your Y. And we can just list them down here. -3 and 5, 2 and 2, 2 and 4, 4 and -1. And I'll let y'all catch up. Okay, so there's what a relation is. Set of ordered pairs. Talked about what it had to look like, and there's different ways of displaying it. Any questions so far? Okay. Domain. Anyone remember what the domain is called? Raise your hand. No one remembers what the domain... Okay, Taylor?
Is that the X?
Yes. Domain is your X. It is a set of first elements of the ordered pairs. That's what it's saying. It's X. It's the set of first elements of ordered pairs. Y'all, it's the X. Domain is the X. I have high school students that have had this class will randomly text me every year. Mrs. Rogers, I forgot what the domain is. It's the X. Oh yeah, that's right. Because if you Google what's the domain, they're going to give you weird explanations, and you got to read through it all to figure out they're referring to the X. Okay? So, try to remember the domain is always the X. All right, range. If the domain is X, then the range is
Y.
very good. It is the set of second elements of the ordered pairs. Do I hear a weird noise?
What the?
Yeah, what is that? Michael, stick your head up there.
I think there are people who be fired like the road.
Oh, they're working?
Sounds like a vacuum.
Yeah.
Okay.
Or they're.
All right, any questions on what the domain and range are? Cecilia, are you still writing notes? Aiden, are you still writing notes? Okay. For example, if I were to say, what is the domain of those ordered pairs up there? Up there. The domain would be of these would be -3. And then I have 2 2s. Do I write them twice? No. And then 4. So if you notice, the domain is your X. Again, I got the X from these ordered pairs. You do not have to write the 2 twice if it's repeating. You just write it once, and you write it in order from least to greatest. So I have -3, 2, and 4. That's my domain. And then the range, again, you're going to list all of your Y's in order from least to greatest. -1, 2, 4, and 5. List in order from least to greatest. And don't repeat numbers. Okay, does everyone know where I got the domain and range from? If you don't, say something. Okay, so this is your X, and I got it from that set of ordered pairs. These are your Y's, listed from least to greatest, and don't write repeats. When you're done, put your pencil pen down so I know that you're done. Okay, moving on. Mapping diagram. Okay, mapping diagram. Some of you might remember domain and range. Same numbers. I'm using the same data, okay, from the same original ordered pairs. Okay, so I'm going to list here the same domain, which is your X, in order from least to greatest, don't have any repeaters. And over here are my Y's. Now, if you look, here's your sets. So -3 goes with what Y? 5. So -3 has an arrow going to 5. And the next one, 2, goes with 2. So 2 goes right across with 2. Y'all see what I'm doing here? And then 2 goes with 4. I'm using the same 2, but I'm drawing an arrow to the 4. And the 4 goes with -1. That is mapping diagram. Any questions about range, relation, domain, range, and mapping diagram? Nothing? All right, let's move on. Function. Special type of relation in which every element in domain is paired with only one element. Notice all my underlines in range. Function. A little bit different than the relation. You got to know the difference. A function is a special type of relation in which every element in domain is paired with only one element in range. So basically, every X is paired with only one Y. Every X is paired with only one Y. It can't have two or more ordered pairs with same first coordinate. Basically, your X. You can't have repeated X's. No repeating x's. X coordinate paired with only one y coordinate. X coordinate paired with only one y coordinate. When you're done writing, put your pencil down. Okay, so let's look up here. Is this a function? Raise your hand. Taylor?
No,
Why?
because it has repeating x's.
See that 2? That 2 is paired up with the 2 and the 4. Therefore, it is not a function because that x is being repeated. Only the x. Notice it's only the x that cannot be repeated. Can you have repeating y's? Yeah. You cannot have repeating x's. So because this 2 is used more than once, and if you look, even if I gave you this, you have a 2 as an x here and a 2 as an x here. This is a relation, but it is not a function because it has repeating x's. Okay,
Alright. Not finished writing down.
where are you at?
X coordinate.
Okay, go ahead. Taylor, if you cannot see, you need to move up.
That's fine.
No, it's not fine. Move up so you can see. You got all this down? All right, move up. All right, so here we go. Is this a function? What's my domain again? Anyone? X. Range is? Y. Good. Don't say anything. I'm going to give you an example. Let y'all copy it, and then we're going to discuss as to whether it is a function or not. All right. Emily, is that a function? Okay, Michael, is that a function? Cecilia, is that a function? Aiden? Whit? Gabby? Taylor? Okay, Emily, why is it a function? Huh? Bingo! No, you're correct. Yes, it is a function. You can have repeated y's. There are no repeating x's. Good job. You're correct. What about this one? Same question. Once you have it down, put your pencil down. How many of you noticed it's the same one we did earlier?
I noticed.
Is this a function?
No.
Why not?
Because it
Because
has,
the X is repeated.
it's a 2.
No, it's not a function. You can't have duplicated x's. Okay. Little tidbit vocabulary you need to know. When doing this stuff, the independent variable is your x. The dependent variable is your y. X is independent, but y always depends on it. Okay,
So it's so we have 3 different names for
yep.
Gordon.
Okay, oh, that leads me into, okay, you're gonna see charts done this way when they mean the same exact thing. I'm just gonna do a couple things. It's gonna be written the same way. Remember f of x? That's a fancy F there. That's a fancy F. Everyone see my fancy F? Okay. So remember f of x? It's the same as y. Remember we talked about that? F of x the same as y? Same thing. But because of what you're doing with functions and stuff like that, they call it different. Because it's dependent on x. X is your independent
So
variable.
it's asking, so whenever it's asking you to find a function, you're looking
You're
for
basically
one.
looking for y. When you're done writing this down, put your pencil down so I know you're done. We're almost done. Okay. Functions are going to look like this. They're going to sometimes look like an F or a Y or even a G. Because Y is dependent on X. It's written, as f of x. So basically your y is your f of x. This whole thing is important. When you're, let's see. When you're done, go ahead and open up your books to page 190 for examples. I'm glad y'all remember this stuff. If you don't, it's okay. All right. Number 1 says state, whether each set represents a relation. Basically, they're saying, is this a relation? So look at number 1. Michael, is number 1 a relation?
Yeah.
Why is it?
Because they're all roots.
They all are your typical X and Y. Right? That's an easy question there, right? Look at number 3, Emily. Why not? There's 3 numbers in there, right? Yeah, that's right. So number 3 is no. They have more than. There's more than just your X and Y. You can only have X and Y. Remember, you can't have X, Y, and Z. Very good. Good job. Does everyone understand that? That's, you just look at and you're like, okay. I mean, and some of you may even be wondering, is it really that easy? Is there a catch to it? You know what I'm saying? But no, it's that easy. Just look at it. All right, number 5. It says, draw a mapping diagram of each relation and state whether, no, don't even draw a map. I want you to look at number 5. Just look at it. Gabby, is number 5 a function? You are correct. Why not? That's right. X is repeating in there. And in fact, like she said, it was the -5, to be honest. It has -5 and 1, and then it had -5 and 2. Because of that -5, it is not a function because there's 2 of them. Does everyone understand that? Cecilia, do you understand? Okay, good. Any questions about that? All right, number 7. Cecilia. That's right, sit up. Number 7. Is that a function?
Yep.
She is correct. How come?
No, X's are repeated.
Perfect. No X is repeating. Now, when you write your answers for homework, you don't have to give explanations. This is for notes purposes, okay? Good job. Any questions about that? All right, number 9. Look how fast we're moving. See, this stuff isn't bad. All right, number 9. It says state the domain and range of each relation and tell whether it is a function. So you're going to have multiple things going on here. I want you to look at your set of ordered pairs. I'm not going to write it all down. That's a waste of time, and y'all can see it in your book. Taylor, first thing you're going to do is tell me what the domain is.
-9, 4, and 6.
Why didn't you, let's see, -9, it's repeated. Why didn't you write -9 twice?
Because you don't repeat them,
You don't repeat them, that's right.
and that automatically means it's not a function.
Wasn't there yet, but he's correct. The answer is not a function. That's the third one, because the -9, you all see that -9 is repeating in there? Emily, do you see it? Okay. So what is the range?
I'm sorry, writing it down.
Okay. Aiden, what's the range?
2, 8, 10, 14.
There you go. And it was done in order from least to greatest. No repeaters. Perfect. This whole thing is your answer. And it is not a function because there were 2 -9s in the domain. $11. Whit, tell me the domain.
$1.3, 1.4, 1.5, and 1.6.
Perfect. What is the range, Michael?
3.7 on all.
So just one, you only write it one time though, right?
Yes.
Emily, is that a function? Yes, she's correct, because even though the range is repeating, none of the domains are. Good job. Any questions so far? All right, let's look at 13. Does everyone have this down? We're almost done. Okay, 13 says for each set, choose a letter of the correct description. Ooh, Gabby. So 13, look at that and then tell me, is it A, B, or C? It is A. It's a relation because you only have an X and a Y for each. And it is a function because there's no repeating domains. Does everyone see that? 15. Taylor.
C.
It is correct. There's like X, Y, Z, so that's not a relation. And because it's not a relation, it's not a function. Because remember, a function is a type of relation. So if it's not a relation, it is definitely not a function. 17, Cecilia. You are correct. It's a relation because they both are X and Y, But oh, look, the domain, the x is repeating, so it is not a function. Any questions? All right, 19. A relation can be represented by a set of ordered pairs, table, graph, or mapping diagram. For each relation, give, oh, that's boring. I'm not doing that. All right, just tell me, 19. Is it a function, Aiden? Huh? Just look at it. Tell me if it's a function.
Yes.
Yes. Good job. How about 21, Whit? Is it a function?
No.
Because there's x's repeating. 23, this is important. This section, my student, and then after we do a couple of these, I'm setting you free. My students get these wrong every time. 23, given the function, all of those ordered pairs, find the following. F of -7. Guys, what is that -7 replacing in the original? Whit?
The Y? Oh, wait.
Remember, it's f of,
Oh,
what goes here?
X.
X. So the -7 is replacing the x. This whole thing is replacing the what? What? The whole thing represents y. So the -7 is in place of the x. So you're looking for the y. So look in those ordered pairs, Gabby, and look for the x that is -7. What is the y? Huh? Yep. Look in the directions. You'll find an ordered pair that's -7 and -4. That -7 is x. It's representing that. So therefore, if this whole thing is y, it's this. So anytime they say f of -7, you're looking for the y. Does that make sense? All right, Taylor, 25.
28.
Yep. Because they gave you f of 6, and one of the ordered pairs says 6 and 28. So if this is f of x, 6 is the x, then the whole thing is 28. So the answer is 28. Any questions? All right, y'all are going to do page 190, 191. You're doing numbers 2 through 26 even, all of you. And remember, for 19 and 20 section, just write yes or no. Don't worry about writing a different way. So for 20 and 22, just write yes or no. So 2 to 26 even. And I'll just call it that. That's it. That's due Wednesday. You have a quiz Friday.
Let's do Wednesday of next week.
Nice try. That won't take you long.